An earthquake measuring 7.8 on the Richter scale struck the Drake Passage, which connects the Atlantic and Pacific Oceans, and a tsunami warning has been issued. The epicenter was located in the ocean between South America and Antarctica at coordinates -60.184, -61.863. The nearest city, the port of Ushuaia in Argentina, is 710 kilometers from the epicenter. The strongest tremor was followed by aftershocks with a magnitude of more than 5. A danger warning was issued. Drake Passage, which connects the Atlantic and Pacific Oceans, was declared a tsunami threat. Ushuaia has a population of 56,800, and the epicenter was located at a depth of 10 kilometers. No casualties or damage have been reported. Following the underground tremors, the Hydrographic and Oceanographic Service of the Chilean Navy, SHOA, issued a tsunami warning for the southern regions of the country. The American tsunami warning system specified that the waves could threaten coasts located within a radius of up to 1,000 kilometers from the epicenter of the earthquake in the Drake Passage. It could threaten settlements on the coast of Argentina. This earthquake fits into the overall picture of a series of underground tremors along the entire Pacific Rim, from Kamchatka in Japan to Indonesia, New Zealand, and so on. Seismologists believe that the powerful earthquake in Kamchatka awakened the Pacific volcanic ring of fire. Scientists have determined the cause of a series of powerful earthquakes in Antarctica. An underwater volcano in Antarctica caused 85,000 underground tremors from August to November 2020. A series, or swarm, of 85,000 underground tremors occurred in Antarctica, the strongest earthquake in recorded history. Scientists who analyzed data from nearby seismic stations and 2 ground-based global satellite system stations concluded that the natural phenomenon was linked to the awakening of a long-dormant underwater volcano. This conclusion is confirmed by the fact that the Earth shifted by 11 centimeters on King George Island. A normal earthquake could not have caused such consequences, unlike the penetration of magma into the Earth's crust during the eruption of an underwater volcano. In addition, the epicenter of the seismic activity was located near the underwater mountain Orca. The culprit behind the swarm of earthquakes is a volcano rising 9,000 meters above the seabed in the Bransfield Strait, located between the South Shetland Islands and the northwestern tip of Antarctica. In this area, the Phoenix tectonic plate is sinking under the continental Antarctic plate, creating a fault zone. An earthquake swarm is an exceptional phenomenon in itself, but its duration usually stretches over hundreds or even thousands of years. Simona Seska, co-author of a scientific paper from the German Research Center for Geosciences, GFZ in Potsdam, summarizes. Similar seismic and volcanic disturbances have occurred in other places on Earth, but this is the first time we have seen them here. So in a way, we were lucky to see it. Studies have shown that the peak of earthquakes occurred in autumn. The strongest earthquakes in the series were magnitude 5.9 events in October and 6.0 in November. Seismologists intend to continue their research and study the differences between the current depth of the seabed in the strait and historical maps. It will probably be interesting for you to find out how often earthquakes occur in Antarctica. Yes, there are earthquakes in Antarctica, despite the fact that they are recorded less frequently and weaker than in other regions. The reason for their apparent rarity has long been explained by a massive ice cap that dampens seismic waves. However, in recent decades, thanks to the installation of modern seismic equipment, it has been proven that Antarctica is prone to earthquakes, often associated with crustal fractures and volcanic activity. Major earthquakes. Strong earthquakes have been recorded in Antarctica. For example, in 1998, a magnitude 8.1 earthquake was recorded, and in 2020, a record 6.0 earthquake was recorded, associated with the awakening of an underwater volcano. Causes of activity. Most earthquakes are associated with fractures of the Earth's crust. Also, one of the reasons may be underwater volcanic activity, as it was in 2020 near King George Island. Are there volcanoes on the Antarctic mainland? Is there an earthquake there often? Are there volcanoes on the Antarctic mainland? Is there an earthquake there often? Antarctica has one active volcano, Erebus, and several extinct volcanoes. Of course, there are earthquakes there, but not strong ones. Antarctica is a tectonically calm continent with low seismic activity. The manifestations of volcanism are concentrated in West Antarctica and are associated with the Antarctic Peninsula, which arose during the Andean period of mountain formation. Some of the volcanoes, especially the island volcanoes, have erupted in the last 200 years. Antarctica's most active volcano is Erebus. It is called the volcano that guards the way to the South Pole. Erebus is a volcano in Antarctica, the southernmost active volcano on Earth. The height is 3,794 m, located on Ross Island, where there are 3 more extinct volcanoes. The volcano has been continuously active since 1972. The Institute of Mining and Technology of the State of New Mexico, USA, has organized a volcano observation station here. There is a unique lava lake in the crater of the volcano. Erebus volcano was discovered in 1841 by polar explorer Sir James Clark Ross, whose ships were named Erebus and Terror. These ships were also used by Sir John Franklin during his ill-fated Arctic expedition. The volcano was first conquered to the edge of the crater by members of the expedition of Sir Ernest Shackleton in 1908. The ship and volcano were named after Erebus, the oldest Greek god born out of chaos. Erebus volcano is located at the intersection of faults in the Earth's crust and is one of the most active volcanoes on the planet. Powerful emissions of deep gases, including hydrogen and methane, periodically occur from these faults, which, reaching the stratosphere, destroy ozone. The minimum thickness of the ozone layer is observed over the Ross Sea, where Erebus volcano is located. In this paper, we study the correlation between changes in the level of Earth's seismic activity and an increase in atmospheric methane concentrations over the past 40 years. Trigger mechanisms for methane emissions and glacier destruction in the polar regions are proposed. These mechanisms are caused by deformation, waves caused by strong earthquakes, in subduction zones located near the polar regions. The Aleutian and Kuril-Kamchatka subduction zones closest to the Arctic, and the Chilean, Sandwich, and Tonga-Kermadec Macquarie subduction zones. Perturbations of the lithosphere are transmitted over distances of 3,000 to 4,000 km or more at a speed of about 100 km/year. Additional stresses associated with deformation waves arrive in the Arctic and Antarctica several decades after the occurrence of strong earthquakes in the Arctic zone. Additional stresses affect the low permeability structure of gas hydrates on the shallow shelf, causing an increase in methane emissions and climate warming. Collapse of West Antarctic glaciers, which has been observed since the 1970s. These waves are also capable of activating dormant volcanoes located under the glaciers of West Antarctica, which leads to an increase in heat flow, melting of ice at the base of glaciers, and their accelerated sliding kilometers per year towards the ocean, as it happens with the Thwaites and Pine glaciers. A numerical simulation of the spreading of the lens of the West Antarctic ice sheet under its own weight was carried out. It is shown that the acceleration of runoff may be due to the effect of slippage at the lower boundary of the glacier due to increased heat flow. In turn, the heat flow increases due to the activity of one of the largest and little studied volcanic provinces on Earth. As a result, the grounding zone during the retreat of the Thwaites and Pine glaciers ceases to be limited by underwater ridges, which can lead to an acceleration of their sliding into the sea, up to the destruction of the entire ice sheet of West Antarctica in a short time, years, decades. In this case, the height of sea level rise may be about 4 meters. The results show a relationship between climate, glacier dynamics, sea level rise, geodynamics, and strong subduction earthquakes. The presented data on the Paleoclimate and the Holocene. The model and calculations show that there are natural causes of global warming.